We are going to be discussing a Sierpinski gasket problem. So the Sierpinski gasket, it starts with a number of steps. What we start with, the number of triangles that we're starting with is one triangle. The perimeter of each triangle is 200, and the length of the boundary is 200. So let's just look at this. That is what we're starting with. The next thing that we need to figure out is after step one, how many triangles do we have? But first, let's talk about which each one of these things mean. So the number of triangles that we're starting with is just one triangle. The length of the boundary is 200. That means, the perimeter of the one triangle is 200, and the length of the boundary is 200 as well. So for the step one, the Sierpinski gasket says we mark the midpoint of each line segment, and then we connect the line segments, and we end up with 4 triangles. But what we do is we take out the middle one. So now we're just left with 3 triangles. So what happens is we started with 1 triangle, and now after step 1 we have 3 triangles. That means that the number of triangles increased by a factor of 3. So we could have figured this out by going 1 times 3, and we get 3. Now let's talk about the perimeter of each triangle. Now the perimeter of each triangle is 200, right? What that means is approximately, if I was going to say the side length of this would be, we would go 200 divided by 3, which is approximately 66.6 repeating. So I'm going to say 0.6 repeating. This side is also 66.6 repeating. And so is this side, 66.6 repeating. Now, when we mark the midpoints of each segment, what happens is we cut that 66.6 in half. So that in half, from here to here, this is 33.3 repeating. And the same is true here. We cut this in half, we have 33.3 repeating, and when we cut this in half, each side, this is 33.3, this is 33.3 repeating though. And 33.3 and 33.3. And then we connect the midpoints, and we take out this one. So now what we need to do is find the perimeter of each one of these triangles. Well, this side is 33.3, this side is 33.3, and this side as well is 33.3. So what happens is when we find the perimeter of this smaller triangle, when we add up all these, what it ends up being, the perimeter of the smaller triangle ends up being 100. And that means the perimeter of this is 100, the perimeter of this smaller triangle is also 100. So the perimeter of each, in step 1, the perimeter of each triangle is 100. And what that is, it's basically the perimeter of each of the smaller triangles, it's 1/2 the perimeter of the big triangle. So 200 divided by 2 actually ends up being 100. Now if we talk about the length of the boundary, let's go back here. The length of the boundary is actually the distance around this triangle, the distance around this triangle, and the distance around this triangle. So we know this is 100, this is 100, this is 100. We could go 3 times 100 because there's 3 triangles, and we come up with the length of the boundary. Another way to look at that is just 3 times 100 is 300. And that's the length of the boundary. Let's go to step 2. Now in step 2, what we're doing is we have to figure out the number of triangles. So the number of triangles is we have to, mark the midpoint here, mark the midpoint here, mark the midpoint here. And we take out the mid one, mark the midpoint here, mark the midpoint here, mark the midpoint here. Take out the mid one, mark the midpoint here, mark the midpoint here, mark the midpoint here. Take out the middle one. And what I want you guys all to do is count up how many triangles are remaining. So if you see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 smaller triangles, which is the same thing. This the step 1 was 3. If it grows by a scale of 3. So 3 times 3 equals 9. That's how many triangles. Now the perimeter of each one of these triangles is actually going to be our, back to here, we're going to mark the midpoint of each one of these things. And we're looking at the perimeter of each one of these. We take that out. The perimeter of each one of these smaller triangles. And the perimeter of each one of those smaller triangles is actually half the perimeter of the step 1 triangle. So 100 divided by 2 equals 50. And that's the perimeter of each triangle. Now, the length of the boundary is we have 9 triangles. They each have a perimeter of 50. So what we're going to do is go 9 times 50, and that's going to give us the length of the boundary. When we go 9 times 50, what we end up with is 450. So then we're going to move on to step 3. Step 3, the number of triangles increases by a factor of 3. So we're going to take how many triangles we had before. We had 9. It increases by a factor of 3, which means at the end of step 3 we will have 27 triangles. The perimeter of each triangle, well, the last step was 50. It is 1/2. It's divided by 2. It's half as big as step 2. So that's going to be 50 divided by 2, which is 25. The perimeter of each smaller triangle is now going to have 25 of its perimeter. And the length of the boundary of now we have 27 smaller triangles, which each have a perimeter of 25. To figure out the length of the boundary, we just go 27 times 27 times 25, and what we end up getting is 675. That's the length of the boundary. We're just going to continue this process. For step 4, we need to figure out what's the number of triangles. Well, we had 27 triangles, and it's going to be increased by a scale of 3. So 27 times 3 equals 81. Well, what's the perimeter of each one of those 81 triangles? Well, it's half of 25. So we're just going to say 25 divided by 2. And when you're doing these problems and you have to have your answer in a fraction, we're just going to leave it like this. There's those little kind of little button things off to the left in your study plan, and you just need to push the fraction one, and then you put 25 in the top and 2 on the bottom, and that's how you enter in an answer like that. And then when we find the length of the boundary for each one of those 81 triangles is 25 over 2. We're just going to go 81 times 25 over 2. We're going to multiply the top, which ends up being 2025, and keep our denominator of 2. And that's what the length of the boundary is for the entire step 4 figure. And then we get to step 5. We're just going to repeat the same process. Each one of those 81 triangles is going to increase in step 5 by a scale of 3, and we end up with 243 triangles. The perimeter of each one of those triangles is going to be half as big as the previous step. So that's 25 divided by 2, which would be times 1/2. divided by 2, multiplying something by 1/2, it means the same thing. It's just two different ways to write it. We're going to multiply across on top, which gives us 25, and then multiply across on the bottom, 2 times 2, which is 4. So that's the perimeter of each one of the smaller triangles, is 25 over 4 in exact form. We could convert that to a decimal, but these particular problems in the study plan prefer fractions. And then if we want to find the length of the boundary, we just go 243 times 25 fourths. And what we end up with is we multiply across 6,075 divided by 4. And that would be the answer to this Sierpinski gasket problem.